Good day everyone, I welcome you back to Global Education Zone. And today in this episode, we'll be dealing with algebraic processes. So algebraic processes are the processes like simplification and substitution that we perform on our algebraic expressions and algebraic equations. So today I'll be talking about um, algebraic processes and I'll be solving some examples. So let's take one for start. Now the first one we'll be taking is we want to simplify by collecting like terms. So that's the first algebraic process, simplification by collection of like terms. So the first example is r minus 3s minus 3t minus 4r plus 10s plus 8t. Now the first step, whenever you see any group of bogus algebraic terms like this, whenever you see a sum of terms like this, what you do is, what you are looking for is the terms that look alike. So the alphabets that are similar, you look for r. This is r, the first one is r. So you write r down. Then which other one has r? Yeah. This one is minus 3s, it doesn't have an r, no r. This is minus 4r. So put it beside that first r, minus 4r. So that is what is known as collection of like terms. So any term that has a similar alphabet is collected together. So next we'll go to s. There's no other r's. There are no more r's. R's are exhausted. Let's go to s now. So this will be minus 3s. What's next? Which other term has an s? No other term. So okay, yes, we have 10s here plus 10s. So we have minus 3t. Let's go to t minus 3t. Which other term has a t? Plus 8t plus 8t. So now we've successfully done what is known as a grouping of algebraic terms. So now we are going to simplify them now. So r minus 4r. So what this means is that is r minus 4r. Basically, it means 1r minus 4r. So you can put the invisible one there, 1r minus 4. And whenever you are subtracting any number like this, that you are subtracting a bigger number from a smaller number, you always get a negative result. So 1 minus 4r will give you minus 3r. So and then next, moving on, we have minus 3s plus 10s. So if you don't understand the question, just swap them and put the plus before the minus. So instead of saying minus 3s plus 10s, you can say 10s minus 3s. So that will be easier for you to understand. So 10s minus 3s will be easy for you to understand, and that is what? 7s. 10s minus 3s is 7s. That's plus 7s. So I said 7s, but I wrote plus 7s. Why? Because anytime you have a positive number, you can omit the plus. So when I said 7s, it also means plus 7s. Now the last one we have is minus 3t plus 8t. Now when the minus comes before the plus, you can swap them. So you can put the plus before the minus. That would be 8t minus 3t. That would be 5t. That would be plus 5t. So now this answer we have here, we cannot simplify them. There are no more like terms, because these r terms are on their own. This s term is on its own. This 5t is on its own. So they are not like. So that's why this will be our final answer for this question. So that is how to simplify algebraic expression by the method of grouping. So moving on, let's move on to the next method of simplification of algebraic expression, and this is known as expansion. So expansion is basically whenever you have anything in a bracket in mathematics and you want to open it up and you want to be able to see the algebraic terms in plain expression, you make use of a technique known as expansion. Very simple, no bogus words. It's just very simple. Just open your bracket. Expansion is just simply opening the bracket. Let me give an example. Find the coefficient of n in, this will be example 2. Find the coefficient of n in 4n plus 3, 4n plus 3, n minus 5, n minus 5, minus 2n minus 3 squared. Now in this question here, we are given two separate algebraic expressions. So we have open bracket 4n plus 3 close bracket, open bracket n minus 5 close bracket, minus open bracket 2n minus 3 close bracket raised to the power of 2. Now following our BODMAS rules, or you can also call it PEMDAS rule, parentheses, exponentiation, multiplication, and so on and so forth. So, but we can also call it brackets, because brackets is also known as parentheses. Now, we will first evaluate whatever is in the parentheses, and that is known as the expansion. So, we expand this term, before we can move on. So, opening this term, we will first of all take one term in the first bracket and use it to multiply every term in the second bracket. So the first term in the first bracket is 4n. So I'm going to take 4n and use 4n to multiply the second bracket, which is n minus 5. So 4n open bracket n minus 5. We'll close the bracket. Then we'll move on to the next term of the first bracket. That will be plus 3. Then we'll use that next term to multiply that same second bracket. That's n minus 5 again. So we've successfully expanded this in one way, but we're not done yet. Let's move on to the next one. That will be minus. Now this 2n open bracket 2n minus 3 square, it means 2n minus 3 in two places. So we're writing it twice. That will be 2n minus 3, 2n minus 3. So moving on here, 4n times n is 4n square. 4n times minus 5 is minus 20n. Plus 3 times n is plus 3n. Plus 3 times minus 5 is minus 15. Why? Because whenever you have a plus and a minus, it always gives a minus. Now, minus, so let's evaluate this one. Let's open it just like this. 2n times 2n is 4n squared. So don't forget to put the brackets. Everything is still in the bracket. 2n times minus 3 is minus 6n. So we are still opening the bracket. Minus 3 times 2n is minus 6n. Minus 3 times minus 3 is plus 9. Anytime you have a minus and a minus multiplication, it gives a plus. Now we've opened this. Now let's open the next one. 4n squared. This will be 4n squared. Now look at minus 20n plus 3n. They are similar, so we can just say minus 17n. So that is the that's the addition of similar terms, of like terms. Then minus 15. Then now this minus will open this bracket. So minus will open everything. And just one cool trick for you, so that you don't stress yourself too much wondering how it's done. Anytime a minus comes before a bracket, it always changes it changes the sign of every term in the bracket. So if the first term was a plus 4, it will change to a minus 4n squared. So this one that was minus will change to plus 6n. This one that was minus 2 will change to plus 6n. Then the last one will change to minus 9. So it basically reverses the sign of every term in a bracket. So, but that is just for minus only. But when it is plus will reserve the sign. It won't change any sign. But minus always changes the sign of every term in your bracket. So next time you are working mathematics and you are opening your bracket with a multiplication of a negative number, always know that your signs will be changed. Now moving on, let's say now this 4n squared minus 4n squared. Let's collect the like terms. Let's collect the n squares, the one that has the second powers of n, the one that has the single powers of n, and the one that don't have powers of n at all. Now let's collect the 4n squared minus 4n squared. 4n squared minus 4n squared. So anyone I've already collected, I will circle them. So now I will circle this and this to show that I've already collected them together. Now minus 17n, I'll collect it with plus 6n plus 6n. That will be plus 12n. Minus 17n plus 12n. So I've collected these ones, and this one. So now what's left? Minus 15 minus 9. That will be minus 15 minus 9 is minus 24. Minus 24. Now look at this. This is 4n squared minus 4n squared. That's a cancel. So it cancels out, and that will leave minus 17n plus 12n is what? Minus 5 minus 5n minus 24. So that would be our final answer. Our final answer is minus 5n minus 24. So now going back to the question, we asked that what is the coefficient of n in this expression? So you look for n. What term has n in your final answer? In our final answer, look at the term that has n. Minus 5n is the term that has n, right? This is the term that has n. Now, what is that number? What is the number beside the alphabet? Now, any number beside an alphabet is known as a coefficient. Now, this minus 5 is the number we seek, and that is the coefficient. So that would be minus 5 is the coefficient of n in this algebraic simplification. So this is the technique also known as expansion and simplification. Now let's move on to another technique, which I will be explaining on with examples. I'll keep explaining them with examples. Another technique we can use in this is let's see about that. We could make use of okay, let me give another example. Now the next example. Now you might have been thinking this video is too simple, right? Is it too simple? Okay, let's give us something that will give you kind of like a tackle. Let's tackle ourselves a bit. Number 3. Now, if x is 2a plus 3, x is 2a plus 3. Guess I might divide the board. X is 2a plus 3 over 3a minus 2. So they said express x minus 1 all over 2x plus 1 in terms of a. Now, breathe in and breathe out deeply so that you can understand the full meaning of this question. What this question is telling you is that it's saying x is 2a plus 3 over 3a minus 2. Now, they are asking us to express x minus 1 over 2x plus 1 in terms of a, whereas x is 2a plus 3 over 3a plus minus 2. So x is just like a function of a. So not really a function, let's just say it is the subject of the equation, because functions, they are different, they are criteria for functions. Now this x is the subject, and then we need to express this another algebraic term in terms of the a term in x equation. So this equation of x, we are expressing it here, and we are expressing both of them in terms of a. So first of all, let's take it step by step. Now this is denominator is x minus 1. So let's evaluate x minus 1. That will be x is 2a plus 3 all over 3a minus 2. So x minus 1 will be minus 1. So that will be, let's take the LCM, lowest common multiple. That will be 3a minus 2. So 3a minus 2 in 3a minus 2 is 1. That's 1 times the numerator. It remains the numerator, 2a plus 3. So 1 times any number will still give you that same number. So this one has an automatic denominator of 1. So whenever a number, in a whole number, any whole number has an automatic denominator of 1. So always remember that. Now the 1 in 3a plus minus 2 will still give us 3a minus 2. Now 3a minus 2 multiplied by minus 1. So as I was saying in the earlier example, I explained that minus 1 will change its sign. So when minus 1 multiplies 3a minus 2, we will have plus 2 minus 3a. So it will simply reverse the sign. So and then at the end of the day, x minus 1 becomes, so let's evaluate the numerator. That will be 2a minus 3a, that's minus 1. 3 plus 5, 2a minus 3a is minus a. 3 plus 2, that's 5, that will be 5 minus a. Then the denominator remains 3a minus 2. So we've evaluated the numerator. Let's go on to the denominator, which is 2x plus 1. So 2x will be 2 times x. X is 2a plus 3 all over 3a minus 2 plus 1. That will be 2. Now this number outside will multiply the numerator. So that will be 2 times 2, 4a. 2 times 3, that's plus 6 all over 3a minus 2 plus 1. So collecting the lowest common multiple, that would be, we still have 3a over minus 2. So 3a minus 2 divided by 3a minus 2 will still give us 1. So 1 times anything will still give you that same. So that will be 4a plus 6. Then next, we have all over 1, an automatic denominator of 1 for any whole number. I stated that earlier. Now 1 in 3a minus 2 will still give us 3a minus 2. 3a minus 2 times plus 1, that will still give us plus 3a minus 2. So the only effect of multiplying a number by 1 is to change the sign, probably. That's if it's minus 1. But if it's positive, if it's plus 1, it neither changes the magnitude nor the sign. So moving on, let's evaluate it. That will be 4a plus 3, that's 7a. 6 minus 2, that's 6 minus 2 is 4, that's over 3a minus 2. So now this becomes our denominator. This becomes 2x plus 1. So let me clean the board so that we can have a better glimpse of this solution. I happen to have cleaned the part of it, but that's not so bad. Now we are trying to express x minus 1 divided by 2x plus 1. So x minus 1 is what? 5 minus a all over 3a minus 2. So let's express it. That will be 5 minus a all over 3a minus 2. So that's x minus 1. Then x minus 1 divided by 2x plus 1. 2x plus 1 is so 2a plus 1 becomes 2x plus 1 is 7a plus 4 divided by 3a minus 2. So we are dividing by 7a plus 4 divided by 3a minus 2. So this will be 5 minus a all over 3a minus 2. So we'll change, whenever you have a division sign, you just change it into a multiplication sign, and then your numerator and denominator will reverse their order. So your denominator becomes your numerator, that will be 3a minus 2 all over 7a plus 4. So you can see that this one will cancel this one, and that will leave us with what? 5 minus a all over 7a plus 4. So you should be prepared for questions like this in your examinations, and this is a sample of how you can be asked to simplify and do things with your algebraic expression. So this method is adding and subtracting algebraic fractions. That is what it's called. So this is the method of adding and subtracting algebraic fractions. Let's move on to the next method of algebraic simplification, and that is factorization. Now in this question, I will be picking a question. I have a question here: y square minus 5y, y square minus y minus 20. So we have an expression. This is the fifth question. We have the fourth. We have y square minus y plus 20. So we are asked to factorize. Now, we are asked to simplify this. Now we'll use the method of factorization. Now this factorization method, it goes thus. You look at the first term and the third term. Now this is an algebraic expression containing 3 terms. The first term is a second order of x. The second is a first order of x, and the third is simply a constant. Now you multiply your constant by the coefficient of your second order. Now that is the number carrying your y square. It has a coefficient of 1, right? So anytime you see a number or an alphabet, any alphabet always has a coefficient of 1. So if you are talking about y square has an automatic coefficient of 1. That will be, we multiply 20 by 1, that will still give us 20. Now you look for two numbers, just two numbers, that when added together will give you 20, and when multiplied will give 20, and when added will give your middle term. And what's your middle term? That's minus y. So what two numbers which when added together will give us 20? So when we multiply the first and third term, that will be 20y squared rather. So what two numbers when added will give minus y, and when multiplied will give 20y squared? So can you think? You might pause the video if you want to think, but basically the two numbers, I figured that out probably before you did. Now the two numbers will be minus 5y and 4y. Yes. Now When we add them together, minus 5y plus 4y to give us minus y, it gives the middle term, and then when we multiply them together, it gives minus 20. So rather, I should have added that this is minus 20, not plus 20. This is minus 20. I made a mistake. This is minus 20. When we multiply them, give us minus 20. So now we are going to replace the middle term by those two numbers, or those two terms we've now gotten. Our new terms, that would be y squared minus 5y plus 4y minus 20. So now we'll group them in twos. So we'll group the first two with the second two. So the first two, we will now look for what number or what alphabet or number is common to both. For the first two, you can say that y is common to both. This y squared minus 5y. Both are expressions of y. So we'll factorize y out, and then we'll see what is left. So when we factorize y out, it's just like taking one y out of y squared. So that will remain another y. So minus 5y. When we remove the y out of minus 5y, it remains minus 5. So that's we factorize y. Then we move to the next two terms. What is common? We have plus 4. Let's factorize 4 out. So when we factorize 4 out of 4y, that will release y. When we factorize 4 out of minus 20, that will leave minus 5. So now you can see that this, we can still factorize something out of this term, because this term is a product of y minus 5 and y. This is a product of y minus 5 and 4. Let's factorize the y minus 5. So let's bring the y minus 5 out. That leaves us with what? Y in the first two grouping, and then it leaves us with plus 4 in the second two grouping. So now it's obvious that we can't collect any like terms again and factorize. So this is going to be our final answer. So y squared minus 5y, y squared minus y minus 20 is also the same thing as open bracket y minus 5 close bracket open bracket y plus 4. So and then this method of factorization is used in the solution of quadratic equations. So I don't know whether you've encountered that, but hopefully in the subsequent episode of this series, we are going to be covering all that in mathematics for high school. Now, thank you for enjoying this video up to this extent, and thank you. Please make sure you like, you share, and subscribe, because I really want to be motivated to continue posting content like this for people like you who are eager to learn. Thanks.